Alright, so here's an example. First thing you have to look at is you want to make sure that you put each side in standard form for a complex expression. So this left side has the real portion, that's the portion that doesn't have the I attached to it, and then the imaginary portion second. Usually it's like A plus BI, that's the standard form for a complex expression. So this would be the real portion, and then this with the I is the imaginary. Once you make sure each side is in that form, then it's pretty easy. This one's already in that form. So we have the real portion and the real portion. So if these are equal to each other, then their real portions have to be equal to each other. So that means 19a equals 7. You can solve that by dividing both sides by 19, and a equals 7 over 19. For b, we just take the imaginary portion. So if these two expressions are equal to each other, then their imaginary portions have to be equal to each other. So negative 17 b equals 1. So then we divide both sides by negative 17, and we get b equals negative 1 over 17. So this was just a basic example. So now we'll go over those other two problems. So remember, we want to get each side in the form of uh, the real portion plus the or minus the imaginary portion. The left side is not in that form, so we're just going to reorder it. So 1 is the real portion, so that's going to be 1, and then plus 2ci. So now we have it in the proper form. We have real plus imaginary. And the right side is already in that form. One thing we have to keep in mind is this whole expression, this negative d plus 6, is the real portion because neither one of them has an I. So anything that does not have an I is a part of your real portion. So I'll put that in parentheses just so we can keep that in mind. And then minus ci. So now once we're in that form where we have real plus imaginary or real minus imaginary on each side, we know that the real portions are equal to each other. So 1 equals negative d plus 6. And we would just solve that um, and add d to both sides. So we get 1 plus d equals 6, and then subtract 1 from both sides, and we get d equals 5. Now we do the same thing for the imaginary portion. Remember, for the imaginary portion, the I tells us the imaginary part. We don't really have to bring it along in the problem. So this is going to tell us that 2c equals a negative c. We want to get all the variables on one side, so we're going to add c to both sides. We're going to get 3c equals 0. Divide both sides by 3, and we get c is equal to 0. Alright, at number 45, each side is already in the proper format. We have the real portion first and then the imaginary portion. So we take the real portions and set them equal to each other. So c squared is equal to d. That doesn't really help us because we're still stuck with two variables. But sometimes if you go to the second part of the problem, which is the imaginary portion, you'll get another piece of information that can help you with the first part. So this tells us that the imaginary portion of the first left side is 4, and the imaginary portion of the right side is d. So that's already solved for. We know that d is equal to 4, and we can use this information and substitute it into our first equation to solve for c. So we know that d is 4, so then we take the square root of both sides, and c is equal to the square root of 4, or c is positive and negative 2.